Okay, we're now on to the surds part of chapter 2, indices and surds. And this is a topic that probably you would have seen before at GCSE, but I'm just going to go through it and kind of assume that you haven't seen it before. So yeah, let's get ready for it. Of course, we'll go through the questions in the textbook later on, but I'm just going to kind of go through initially what are surds. Okay, so what is a surd? A surd are numbers left as square roots that give irrational, so decimals that do not terminate, do not finish, numbers. So for example, root 5, it is a surd because if you put this into your calculator, you get 2.23606, and this decimal keeps going on forever and ever. It doesn't repeat, it never terminates, it never stops. Therefore, root 5 is a surd, okay, because you can't write it as a whole number, an integer. So there we go. Okay, this number is irrational. It goes on forever with no recurring pattern. It does not terminate. Therefore, root 5 is a surd. Okay, so this thing is a surd. So let's look at some examples of which are surds. So the first one, right, is the square root of 1 going to be a surd? It isn't, because if you square root 1, of course you get plus or minus 1, but here we're just looking at the positive. You get 1, because 1 times 1 is 1. And because 1 is an integer, a whole number, root 1 is not a surd, because it can be simplified to give you an integer of 1. Okay, therefore root 2, thinking about it, is root 2 going to be a surd? Yes, it is, because if you put root 2 into your calculator, you're going to get 1.41421, and it will never ever terminate. It just keeps on going forever and ever. Okay, therefore, root 2, okay, because it gives you an irrational decimal, okay, it does not finish this decimal, root 2 is a surd. And therefore, similarly, root 3, okay, is a surd because root 3 gives you, again, an irrational decimal. It never terminates, it never stops. Therefore, root 3, it is a surd. So root 4, because it's a square number, okay, is not a surd because the square root of 4 is equal to 2. And because 2 is a whole number, you can simplify root 4 to give you 2. Root 4 is not a surd. Okay, so you can think about a surd as being something that you can't simplify down. Okay, so right, 1 and 4 are not surds because they are your square numbers. Okay, you can simplify them down. Good, so that's the kind of the very fundamentals of what a surd is. And then this stuff below, I think this is the final slide for the first lesson on this, is just this. Okay, a few little things just to remember. Right, remember from our work on indices that the square root of x is exactly the same thing as x to the power of a half. Okay, and that's useful to know, okay, because we can write surds as indices, which we know. For example, okay, that's one example, root x. If you were given the cube root of x, okay, well, what's that going to be the same thing as? That's the same thing as x to the power of 1 over 3. We learned that from our laws of indices previously. Okay, so because we can write surds as indices, which you can see here to here, surd, indice, surd, indice, all of the laws of indices apply to surds. Okay, so everything we've seen previously, right, on our work on indices also applies to surds because they're the same thing, just written in different ways. Okay? So for example, like we're going to look at this law down here, okay, and we saw something like, I don't know, we saw, let's do it in red. So using this first law here, okay, the multiplication law, if you had something like the root of a times by the root of a, okay, you can simplify this down further. Personally, right, if I'm ever given something in a surd form, I always convert it back into indice form because it's easier just to deal with. So this we can rewrite. Root a is the same thing as a to the half, timesing it by a to the half. Okay, and we know laws of indices, timesing add the powers, half at half is 1, so it just gives you 1, so it gives you just a. So you can see, right, we can apply the laws of indices, everything here, to surds, because they are the same thing really, just written in different formats. This is written in surd format, this is written in indice format. Okay, that is it for this video. Just a very quick introduction to what surds are and just recognizing you can apply all of the laws that you know on indices to surds. Thank you.